This video is explanation regarding binary operator of an C programming language and the various types of binary operators. Binary operators, the classes of operators that act upon two operands to produce a new value are known as a binary operator. An expression involving a binary operator will be consisting of one operator and two operands. The different types of binary operators are arithmetic operators, relational operators, logical operators, bitwise operators. Arithmetic operators. The arithmetic operators perform arithmetic operations. The arithmetic operators can operate on any built-in data type. A list of arithmetic operator and their meaning are especially we use the arithmetic operator for the purpose of performing the operations such as addition, subtraction, multiplication, division and modulus. The various kinds of arithmetic operations are plus, addition or unary plus, minus, subtraction or unary minus, asterisk, multiplication, backslash, division, percentage symbol, modulo, division. Suppose a and b are integer variables whose values are 100 and 400 respectively. Several arithmetic operations involving these variables together with the resulting values are. This table shows the expressions and the corresponding value which we get upon evaluation of an expression. So for example, a plus b, since we have considered a value as 100 and b value as 4, so a plus b will give 104, a minus b will give 96, a into b will give 400, a slash b, that is a divided by b, will give the value as 25, a mod b will give the value as 0 because 100 divided by 4, the remainder will be equal to 0. Relational operators. Relational operators are used to compare logical, arithmetic and character expressions. Each of the relational operators takes two operands. Each of the operators compares their left hand side with the right hand side. The whole expression involving the relational operator then evaluate to an integer value. This value will be equal to 0 if the condition is false and it will be equal to 1 if it is true. Relational operators comparison ಗೋಸ್ಕರ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಲಾಜಿಕಲ್, ಅರ್ಥಮೆಟಿಕ್ ಮತ್ತು ಕ್ಯಾರೆಕ್ಟರ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್ ಕಂಪ್ಯಾರಿಸನ್ ಮಾಡ್ತೀವಿ. ಈ ರಿಲೇಷನಲ್ ಆಪರೇಟರ್ಸ್ ಅಲ್ಲಿ ಎರಡು ಆಪರೆಂಟ್ಸ್ ಇರುತ್ತೆ. ಅವರ ಲೆಫ್ಟ್ ಸೈಡ್ ಅಲ್ಲಿರೋ ಆಪರೆಂಟ್ ವಿಲ್ ಬಿ ಕಂಪೇರ್ಡ್ ವಿತ್ ದ ರೈಟ್ ಸೈಡ್ ಆಫ್ ಅನ್ ಆಪರೆಂಟ್. ಒನ್ಸ್ ಟೈಮ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಎವಾಲ್ಯೂಷನ್ ಆಗುತ್ತೆ. ಎವಾಲ್ಯೂಷನ್ ಆದಮೇಲೆ ಇದು ಇಂಟೀಜರ್ ವ್ಯಾಲ್ಯೂ ಕೊಡುತ್ತೆ. ಇಫ್ ಇನ್ ಕೇಸ್ ಕಂಡೀಷನ್ ಏನಾದರೂ ಫಾಲ್ಸ್ ಇದ್ದರೆ ವ್ಯಾಲ್ಯೂ 0 ಅಂತ ಕೊಡುತ್ತೆ. ಇಫ್ ಇನ್ ಕೇಸ್ ಕಂಡೀಷನ್ ಏನಾದರೂ 2 ಅಂತ ಬಂದರೆ it will give the value as 1. This table gives the various types of relational operator and their meaning. First one is a greater than, less than, greater than equal to, less than equal to, equal to. We can observe that equal to is consisting of two assignment operators. Not equal to, that is a negation and assignment operator. Let us consider two integer variables a and b with the values 100 and 4 respectively. Several relational expressions involving these variables and together with their resulting values are. This table gives the expression, interpretation of that expression and the value which is going to give. First one, a greater than b. Since the value of a is 100 and b is 4, this condition will be evaluating to true. Therefore, the value it will be returning will be 1. Similarly, a less than b, 100 is less than 4. This condition becomes false. For that purpose, it will return the value as 0. Similarly, a greater than equal to b will be returning true and the value will be 1. A less than equal to b will be interpreted as an false and it will be returning the value as 0. A equal to b, 100 equal to b, condition becomes false, therefore it will give the value as 0. A not equal to b, 100 not equal to b. This interpretation, that is the result, will be true, therefore it will return the value as 1. Logical operators. This class of C operators is used to make additions. There are three types of logical operators, namely AND, OR, NOT. The first two are the binary operators and the last one is a unary operator, that is AND OR the binary operator, NOT is a unary operator. The result of all these operators will be resulting either true or false. The logical operators are used to connect one or more relational expressions. For example, A greater than B and A greater than C. This particular table shows the operators which is used for the purpose of AND or NOT representation. First one, logical AND, it is represented by double ampersand symbol. Logical OR, it is represented by double pipeline. Logical NOT, it is represented by an exclamation mark. AND operator. The logical AND operator is used to perform ANDing operation on two logical operands. It performs the multiplication operation. The result of the logical ANDing is true when both the operands are true, otherwise the answer is false. The following truth table illustrate this. This is the truth table of an AND operator. Operand 1, operand 2, operand 1, ampersand, that is a double ampersand that represents an AND operation, operand 2. As we know, the AND operation will be true if both the operands are true. In all other cases, it will be false. For that purpose, according to this table, we can see at the last row of the AND operation is true because both the operand 1 and operand 2 are true, whereas in other cases it is false. OR operator. The logical OR operator is used to perform ORing operation on two logical operands. The performs the logical addition operation. The result of logical ORing is false when both the operands are false, otherwise the answer is always true. The following truth table illustrates this. It is the truth table of an OR operation. Operand 1, operand 2, operand 1, double pipeline that represents the OR operand 2. In this we can see the OR operator will be false if both the operands are false. In other cases it is true. NOT operator. The logical NOT operator is used to obtain logical complement or inverse of a given operand. The result of a logical NOT is true when the operand is false and vice versa. That means if it is false, then it will be true. The following truth table illustrates this. This table shows the NOT operator truth table. Operand, negation of operand, that is not of operand. If it is false, it will be true. If it is true, then it will be false. Suppose that A and B are integer variables whose values are 100 and 4 respectively. Several expressions involving these variables together with the resulting values are. Let us consider the first expression, A greater than B and A equal to 100. Here the value of A is 100 and B is 4. So 100 is greater than 4 condition becomes true, and A equal to 100, this condition also become true. Since both the conditions will be true, therefore the interpretation of this expression is true. Therefore the value it will be returning is 1. Second one, B greater than A or A greater than B. B greater than A, it is 4 greater than 100, condition becomes false. The next one, 100 greater than 4, condition becomes true. False or true, here the interpretation, that is the resultant upon evaluation, will be true. Therefore the value it will be returning is 1. Not of A greater than B, 100 is greater than 4, condition is true. Since there is a negation operator has been applied, it will be interpreted as an false, that is, it will give the result as an false. Therefore the value will be equal to 0. When we are using a logical and both the conditions should be true, then only the resultant will be true. If any one of them is false, the resultant will be false. In case of an OR, it is a logical OR. If any one of the condition is true, then the resultant will be true. If both are false, then the resultant will be false. In case of a negation, it is a logical NOT. The result will be always the opposite of the operand or opposite of a condition. If it is true, then it will be false. If it is false, then it will return the true value. Bitwise operators. Bitwise operators operate on an individual bits of an integer values. This is useful for the purpose of writing a low-level hardware or an OS code where the ordinary abstraction of numbers, characters, pointers, and so on are insufficient. Bitwise operators individual bits ಮೇಲೆ ಆಪರೇಟ್ ಆಗುತ್ತೆ. ಇದನ್ನು ಜನರಲ್ ಆಗಿ ನಾವು ಲೋ ಲೆವೆಲ್ ಹಾರ್ಡ್ವೇರ್ ಅಥವಾ ಆಪರೇಟಿಂಗ್ ಸಿಸ್ಟಮ್ ಕೋಡ್ ಬರೆಯೋದಕ್ಕೋಸ್ಕರ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಎಲ್ಲಿ ನಂಬರ್ಸು, ಕ್ಯಾರೆಕ್ಟರ್ಸು, ಪಾಯಿಂಟರ್ಸ್ ಮತ್ತು ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್ ಇನ್ಸಫಿಷಿಯೆಂಟ್ ಇರುತ್ತೆ, ಅಲ್ಲಿ ಬಿಟ್ವೈಸ್ ಆಪರೇಟರ್ಸ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. Bit manipulation codes tend to be less portable. Code is portable if without any programmer intervention it compiles and runs correctly on different types of computers. Bit manipulation code less portable. Portable ಅಂದರೆ ಎಲ್ಲಿ ನಾವು ಇಂಟರ್ವೆನ್ಷನ್ ಇರಲಾರ್ದಂಗೆ ಕಂಪೈಲ್ ಮಾಡಿ ಮತ್ತು ರನ್ ಮಾಡ್ಬೋದು ಬೇರೆ ಸಿಸ್ಟಮ್ಸಲ್ಲಿ. ಅಂದರೆ ಒಂದು ಸಿಸ್ಟಮ್ ಮೇಲೆ ಕಂಪೈಲ್ ಮಾಡಿ ರನ್ ಮಾಡಿದನ್ನ ಬೇರೆ ಸಿಸ್ಟಮ್ಸಲ್ಲಿ ಕೂಡ ಏನೂ ಚೇಂಜಸ್ ಮಾಡಲಾರ್ದಂಗೆ ರನ್ ಮಾಡ್ಬೋದು. ಅದನ್ನು ನಾವು ಪೋರ್ಟೇಬಲ್ ಅಂತ ಕರಿತೀವಿ. ಅದರ ಬಿಟ್ ಮ್ಯಾನಿಪುಲೇಷನ್ ಕೋಡ್ ಬಂದು ಪೋರ್ಟೇಬಲ್ ಅಲ್ಲ. ಇಟ್ ಈಸ್ ಡಿಪೆಂಡಿಂಗ್ ಅಪಾನ್ ದ ಮೆಷಿನ್. Bitwise operations are commonly used with unsigned types. These operators perform bitwise logical operations on the values. Both operands must be of same type and width, and the resultant value will also be of the same type and the width. All data items stored in a computer memory will be always in a sequence of bits, that is, by zeros and ones. Manipulation of individual bits is carried out in a machine language or in an assembly language. To perform bitwise operation in case of C programming, it provides 6 bitwise operators. Bitwise operators are bitwise negation, bitwise and, bitwise or, bitwise exclusive or, right shift operator, left shift operator. This particular table gives the bitwise operations way of calculation. For example, consider the bit A and bit B values as 0011, 0101. In case of an bitwise AND, the resultant will be 1. If both the bits are 1, in all other cases it will be 0. So that we can see in the third column. The next one, bitwise OR. In this case, the resultant will be 1 if any one of the bit is 1. If both the bits are 0, then the resultant will be 0. That we can see in the fourth column as 0111. Exclusive OR. Here the resultant bit will be 1 if the bits are of different values. That is, if it is 0 1, it will be 1. If it is same, that is, if it is 0 0, the resultant will be 0. If it is 1 1, the resultant will be 0. Then negation, that is an negation, that is a unary minus, that is just the resultant will be opposite of the bit. If it is 0, it will be 1. If it is 1, it will be 0. That we can see in the last column of this particular table. We shall see examples with respect to bitwise operators. First one, bitwise negation. A equal to 6 zeros followed by 2 ones. Its negation will be negation of A equal to 1 1 1 1 1 1 0 0. That is, all the zeros will be now 1 and ones will be zeros. Then bitwise AND. Consider 2 A and P as the values, 6 zeros 1 1 and P value as 3 zeros 1 0 1 1 0. When we perform the bitwise AND, it will be noted as A ampersand of P equal to 0 0 will be equal to 0 0 0 0. Again 0 0 will be 0 0 1 will be 0 0 0 will be 0 0 1 will be 0 1 1 will be 1 1 0 will be 0, because the ANDing of bits will be 1 if and only if all the bits are 1. Otherwise it will be 0. Bitwise OR. Consider A and B with these bit values. Now when we perform bitwise OR, that is a P or P equal to 0 0 will be 0 0 0 0 0 0 will be 0 0 1 will be 1 0 0 will be 0 0 1 will be 1 1 1 will be 1 1 0 will be 1, because when we perform bitwise OR, if the bits are 0, then only it will be 0. In all other cases it will be 1. That is, if it is 0 1, it will be 1 1 0, it will be 1. If it is 1 1, then also it will be 1. The next, bitwise exclusive OR. Consider the A and the B as with these bit values. When we perform bitwise OR, A bitwise OR B equal to 0 0 0 0 0 0. Then again 0 1 will be 1, 0 0 will be 0, 0 1 will be 1, 1 1 will be 0, 1 0 will be 1. Because when we performing bitwise exclusive OR, if the bits are same, then it will be 0. If the bits are of an opposite values, then it will be an 1. For that purpose, if it is 0 0, it will be 0. If it is 1 1, it will be 0. If it is 0 1, it will be 1. If it is 1 0, then it will be 1. Right shift bitwise operator. Consider A equal to 4 zeros, 0 0 1 1, that is nothing but its decimal equivalent is equal to 3. When we perform right shift, that is A right shift of 1, then it will be equal to 4 zeros 0 1 1 0, because we have just shifted one bit on the right side. Now it will be equal to 6. Another one simple way of calculating this one will be, how many number of bits you are shifting, just multiply those number of bits with the power of 2. That is, since we have been shifting only a one bit, 2 to the power of 1 will be 2. So 2 into 3 will be equal to 6. Then similarly, another one example, A shifting of 2. So this will be equal to 0 0 0 1 1 0 0 0. So here initially it was 6. We have shifted 2 bits. The 6 into 2 to the power 2. It is 2 to the power 2 is 4. 4 into 6 is 24. Or else you can directly calculate by considering these binary numbers also. Then A right shift of 3. This will be equal to 1 1 0 0. After that 4 zeros, it will be equal to 192. Left shift bitwise operator. Consider A equal to 1 1 0 0 0 0 0 0. This will be equal to 192, that is a decimal equivalent. When we perform left shifting by one bit, it will be equal to 0 1 1 0 0 0 0 0. So this will be equal to 96. How we can calculate is, directly you can calculate by converting this binary number to a decimal number, or 192 is the earlier value. Since we have shifted by one bit, so here 192 divided by 2 to the power 1. So 192 divided by 2 will be equal to 96. A left shift of 2. So this will be equal to 0 0 0 1 1 0 0. This will be equal to 24. Since he has shifted by 2 bits, so 96 divided by 2 to the power 2. So 2 to the power 2 is 4. 96 divided by 4 will be equal to 24. Then A left shift of 3 bit will be equal to 4 zeros, then 0 0 1 1. This will be equal to 3. Since we have shifted by 3 bits, so that is 24 divided by 2 to the power 3. 2 to the power 3 is 8. 24 divided by 8 will be equal to 3. Or else you can directly calculate by considering the binary numbers and converting them to an equivalent decimal number. Click on like and subscribe button for more information.